different things. Now, it's asking, when is it increasing? Now, increasing, Brett, you guys know when it's going up. When is it increasing, Travis? You know? It starts, well, we're going to start here at, it starts increasing at 0 and -3. Okay? So it goes from 0 to -3. Where else, when does it stop increasing? According to the graph.
It never does.
Well, it never does, but you're right, it doesn't. But at 8 and 10.
10.
8 and 10. Because that's the highest point of where we have. All right, so that's when we see it's increasing. You all see that?
Yeah.
Makes sense?
Sure.
Greg?
Yeah.
All right, then it's asked, when is it decreasing? Well, when does it start decreasing?
Never.
Well, we're going to start, it starts decreasing here, doesn't it? At -8 and 10?
Why does it start increasing from 0 to -3? Why -3? I'm understanding maybe the 0.
Okay.
Why -3? Shouldn't it
All right.
stop at 10?
Okay, let's take a look here. Let's start right here. We're going to come to that. That's a turning point. At that point, it's no longer decreasing, it's increasing. It's going up. That makes sense? So where does it start going up?
-3.
Well, we would call that point 0, -3. Now, if I were to say where on the y-intercept does it start turning, it starts turning at -3. But if I ask what is the coordinate, or what is the
0, -3.
0, -3. So it starts at 0, -3,
Oh, yeah.
and then it goes up to here, which JJ brought up, it doesn't end, which is right. But for the purpose of this graph, I want to say
It should stop right there.
it stops there. It stops, or keeps going until 8 and 10.
Yes.
You get that, Greg?
Yes.
Okay, now decreasing is the same thing. It decreases from this point down to the bottom point. That first part we see on the graph is -8 and 10. Does that make sense?
Yes.
And where it stops is 0 and -3. At that point, it's turning, and it goes to
Please stop.
increasing. All right, any question on that first part?
No.
All right, let me get rid of these so we can
Wait,
see.
it's 8 and -10.
Yep.
No, yeah.
I'm
No,
sorry,
-8.
-8 and 10.
I'm trying to get ahead of you. Why is it back so small again?
Because I want to see the whole page. I want to see the graph and the questions. That's the only way I can make it.
What, the eraser?
Oh, the eraser, I just mess up every time. All right, number 3. When is the graph positive?
When it goes past the negative.
Well, remember we talked about, and I'm going to have to ask about this one. This is positive parts. All right? So when it's above the x-axis. Does that make sense to you guys?
Uh-huh.
When is it negative?
When it's below the x-axis.
All right, so when it's below the x-axis, and this is where it's below the x-axis in blue. All right, everybody got that so far?
So above, what was the turning point?
Well, we didn't get to that yet. I'm sorry, what is the turning point? All right, isn't this right here the turning point?
Yeah.
So -3.
Not -3.
-2.
What's the full?
0.
0, -3. Because -3, Greg, -3 is all this. This is all -3. I want to know exactly where along that is that -3. And it's at 0, -3.
So
it's
positive above.
Positive is above.
X, and it's below. It's negative below X.
Right, so the green is positive, the blue is negative.
Okay, you just answered my question.
Okay, good.
You went out of line.
I'm closer to being in the line.
Now I understand all this.
Alright.
I remember this all from last year.
Good. What are the maximums? What's the highest points? The tips?
9.
Okay, so the tips right here.
Yeah.
I'm going to just give them names. It's
Looks like it's my corn.
-8 and 10, and 8 and 10. Okay, so those are the maximums. Now, Travis, where are the minimums? What's the minimum?
33.
Well, that's the y part of it. What's the x part? Give me the whole thing. This is the minimum. Exactly where is that point?
Oh.
Because you're telling me it's -3. Yeah, this is all -3, but I want to know what exactly that point is. Take a Someone help him out. Yeah, JJ.
0.
0, -3. So Travis, this point right here, that's the lowest point. That is the point 0, comma, -3.
So
Got it?
the minimums are going to be called 0, -3.
Not always.
Well,
In this
no,
one,
for that one.
for that one, the minimum is 0, -3.
I'm sorry, I'm not speaking in full sentences right now. I'm just going my nose is stuck.
That's
I
fine.
just woke up. I'm sorry.
Okay.
When it's on that big black line,
Now that's the only minimum
It's
for
0.
this one.
For this one, you can have other ones where there's
Yeah.
more than one minimum. But this one is. Alright,
Some more.
yeah,
Notes recorded.
I know. I told you I was recording. Alright, I'm gonna go on to number 8. Everybody okay with that?
Yes, we're all right with that. That's fine.
Okay. Number 8. Is it continuous or discrete?
It's continuous.
Why is it continuous?
because there ain't no dot, it's a straight line.
Alright, because there ain't no dot. It's, it's continuous because all the points are connected.
Yeah.
All
Okay.
the points are connected.
Yep.
So continuous.
Now,
all the points are connected.
Jay, there's nothing, you're on the right track by saying, but it does, the way you say it is, all the points are connected.
Yeah, like a
Um,
stop.
Or it includes all the points. Yes, Greg,
I can write this all down, but I don't fully understand. What do you mean by all the points are connected?
okay. When we talked about discrete or continuous, all this right here, take a look up here, Greg. If I put a point right here where that dot is, that point is something like 3.75, comma,
2.8.
1.1.
Yeah,
All
I
right.
know what it would be like.
So it would include that number. It would also include one step over, 3.75, comma, 1.12, 11.
Why would it get that one?
Well, it includes all those numbers. If I tell you the opposite of continuous, you may understand. If I were to graph it, and if I were graphing something, and instead of using a line, I were to do this,
Like a line graph.
this is discrete, because they're individual points. Now, one of the points happens to be this one right here, which is -4 and -2. That's one of the points. All right? This one is not one of the points because it's not a discrete point. Discrete means they're individual points. All right? Continuous means it includes all the points. Because if you think about numbers, when people think this gets kind of stupid, if I were to say the number 1, what's the next number after 1? What's the number after 1? Well, I can say no, 1.5 is next. Is that in between 1 and 2?
Yeah.
Are there any numbers between 1 and 1.5?
Yeah, 2.5.
1.2.
Okay. How many numbers are there between 1 and 1.5?
4.
There are an infinite number of numbers.
Oh yeah.
So it includes all those numbers. You start doing this sort of stuff, you can have 4.2, 4.21,
So all of
4.23.
them could be all the numbers.
Right.
All of them could be
So the only way we have to show all the numbers is by using a line. Or something, a continuous, to say that it's a continuous relationship. Alright, yeah, Jake.
When you done that 3.111,
Uh-huh.
wouldn't you put a line over the 1?
Well,
Just repeating
if
itself?
I were telling, well, that may be a number 3.111, and that's where it stops.
Yeah.
But if I were to put a bar over that
That
means
means that 1 kept going.
right. But unless I put that bar, that means it doesn't repeat.
Like 1.3333, you put the 3, you put the line over
If
the 3.
in that case the 3 repeats.
Yeah.
But if I don't put the bar, you can have this number. This is a number that stops right there.
Stop.
But if I put this on it, that means that 5 repeats.
Kept going.
All right, but I'm leaving the bar off these ones.
Okay. I just
Alright.
wanted to make sure.
Now for the hard stuff,
Oh no.
the stuff that you will learn to love.
No.
All right, number 9. What is the domain? Now, are you smashing it vertically or horizontally? How do I do, Jay? Okay, so if you were to smash it, you'd smash it, you'd get this. Smashing a domain. Everybody okay with that?
Yeah.
All right, so Benito. So, Jessica, you okay with this smashing hamburger stuff? If I were to smash it this way, no, not like that, like this.
This is hamburger, this is hot dog.
Right, so hamburgers next, hot dogs and wash. All right, so if I were to smash the hamburger, it's going to go like this, isn't it? So that would be all the real numbers. Everybody okay with that?
Yeah.
Alright, and this will be on score/YouTube for your perusal later on. Alright, number 10, are there any restrictions on the domain?
No,
No, because it goes on in either direction forever.
there ain't no stopping.
Right, there's no stopping point. That's a good way to think of it. Hold on a second.
No.
No, if it goes on forever, there's no stopping point.
Yeah.
Number 11. Jeremy, if I'm doing the range, am I doing a hamburger or a hot dog?
Hamburger,
Range.
hot dog.
Hot dog. So it's going to be like this.
Mhm.
Alright, so if I smash the range, it would come up like this, smashed together. Everybody got that? Vito, you got it? What? The glare?
Yeah.
Alright, so I'm going to smash the range. Where does the range start on this graph?
0.3.
Okay, 0, we're just going to call that -3, because that's where it starts on the y. So it starts at -3, does it go up from -3, or
Yeah.
does it go down?
Higher than negative.
So it's going to, it will be greater. So we would write it like this. X is greater than or equal to -3. That's the range.
Wait, that line underneath the alligator is equal to?
Right. This means, the first part means greater than. You add that little line that means greater than or equal to.
Oh, okay.
Alright, let me get rid of some of this stuff so we can do number 12. Travis, you knocking things over back there?
No, put it in chair.
He's having a stab.
I see that. Maybe Jessica's getting tired of you getting rid of the book.
No, it's a class, I had a class last year of kids like K1, J.
Alright, what is the y-intercept? Where does this one cross the y? Oh, you've been answering a lot of questions, you've been doing a great job. Jessica, where does this cross the y-intercept? You have the same thing as me if you have trouble seeing that. You know? You know? Okay. You know where it crosses the y-intercept?
I can say about the
Okay. Let's take a look at one of the guesses. JJ, great. One of the guesses is 0. Does it cross the y-intercept at 0?
Yes.
The y-intercept is this, right here. This is the y. Where does this thing cross? Does it cross right here?
Yes.
Okay, so what is that point on the y?
The interception.
And that's -3.
Yes.
And more importantly, what's that represent in this case?
Where it's increasing.
Okay. We've actually given that 2 terms. That's a turning point.
Yeah.
Okay, it's the turning point where it goes from decrease to increase. It's also the minimum. We gave that another word. So in other shapes it may be different, but in this case it's the turning point and the minimum. 13, we're almost done. What are the x-intercepts? Where does it cross the x? Let's have some besides JJ. JJ's doing a good job, but I want to hear other people. This is the x. Let's hear from Brett. Brett, where does that cross the x-axis?
That's when it comes down around, right?
Yeah, you want to come around this circle so I know what you're talking about? You can. And that's the y. Where's it cross? The x is this right here. Where's it cross that? That's right here. Okay. Okay. All right. Where is it? Where else is it cross? On the other side, right? Okay, good. Let's see if we can make it a little better. All right. Brett is correct. These are the 2 spots. That's where it crosses the x. What are those 2 values? It's +3
Negative.
and -3. And this one, it doesn't really represent anything. It's where it turns.
Yeah.
Now, if it was a graph, I'm talking about real world things, it probably means something. Last one, is that rate of change constant?
Yes.
No.
No.
What's the only thing that has a constant rate of change?
Linear.
Linear, very good.